Hello, we are back and we now continue our lectures of solving large and dense linear system of equation. Okay, as a part of the lecture of the subjects 206222, okay, for the sophomore student in industrial engineering at Kasetsart University. Okay, as you see on the screen, this is the my own personal drive that share with you. And certainly today we will move from all illustrated example from Excel file to what we call the new platform we call the Matlab programming. Okay, as I mentioned before that our university has subscribed the university license for Matlab that you can uh, install, okay, and try to use it, okay. uh, okay, let me recall it again that okay, you just go to engineering.ku.ac.th, okay, this website, and then you see this, okay. This is actually in Thai, but this one is the one that I show you, the coming from what I mean the information system, okay. And then you can go to this information system, and then you can see the Matlab here over here. You click Matlab over here. Okay, you can click over here this green button or virtual button. You can the campus wide license. This is under the account of at ku.th. Okay, you can install it. And once you install the Matlab, okay, this is what you will see, okay, on your personal screen, okay, that uh, you see you can have this Matlab. I still haven't installed the latest version yet. I have this 2020 version where it's still workable over here that I already installed, and then I already download a set of program that appear here on my Google Drive. Or okay, let me go back here. My drive of lecture 206222. Okay, you go to the room called 2024, and then you can have another sub to folder of Excel that we have used a lot from the previous lecture. Okay, this is the lecture file for the Excels. Okay, and today we move to this folder called the Matlab file. Okay, I think there's a plane passing. Okay, so you can hear the, the sound a little bit. Okay, my house is pretty close to the Suvarnabhumi airport. Okay. Okay, so within this subdirectory of Matlab file, you can see a lot of file happening here. Okay, we will in this part of the lecture, okay, we will try to cover all of this, okay. But today we start with a set of program that I already load and install over here. Okay, and after I install the Matlab University Campus Y license, okay, I can download all the programs, okay, over here. Okay, this is all uh, the .m. Okay, this is the surname of the all the Matlab program. Okay, I already install. Okay, yeah. Okay, retrieve it over here. Like this is the first file we call the construct metric partitioning m by m dot m. Okay, if you see on the screen. Okay. Okay, and then you have some example of the read file and the write file. How to write. This is the way the example prototype for you to communicate with the hard disk. As as you already seen when we work on the Excel platform that we are working on the very large metrics that the general main memory have a problem to work on it simultaneously with all the data in the matrix, right? So we need the secondary storage to store the part, and then we're going to retrieve some necessary part that when we working on the mathematical operation or expression, it have it's still within the comfortable zone of the machine response. Okay, within the manageable side. Let's just say it that way. Okay, like I'm going to start with this one first. This is the program they say we call the read n by n matrix. For example, I'll explain you line by line the meaning of this uh, of the code over here. The first statement we call clear. Clear is mean that whatever you run it the program before, they're gonna clear all of them out so that you can have the full strength of your remaining memory. Okay, so clear is quite necessary as a start when you're trying to run any program, unless that you want some remaining result from your previous program and then continue to work on this program. Okay, otherwise, okay, you should clear all the previous results that occupy the main memory. And then you can have a set of command we call tick and talk over here. You can see that tick on line 2 of the program, and then talk is at the end of the program over here. Tick-tock is mean that you're trying to have a stopwatch, right? The tick is a start the stopwatch. Talk is a stop the when you stop measuring the time when once you execute the command after the tick command. It means that okay, after if you put tick over here and you put talk over here, they will measure the processing time of executing a set of command, okay, Matlab command between the tick and talk command. Okay, so this one is like I try to measure the time. Okay, so I set up what do I'm executing? Okay, this one just okay, I'm gonna go with the n1 is equal to 10. It means that and then I'll go to A11 is a zeros of N1 and N1. This one is like a matrix of for the storage. N1 is the dimension of the matrix 10, right? A11 is 0 is the initial metric. Put all the 0 element in N1 row and N1 column, right? So this one is we set up a metric called A11, okay, with the size of 10 by 10. Okay, and if we want to read this the data from the file, okay, we call capital A11 over here. First you need this set of command here, file ID equal to fopen and the name of the file. You must remember that this file must be constructed first. Okay, you remember that the very first program that I tell you is this file. This file we can construct the matrix, okay, and put it in the secondary storage. We will come back and explain this word by word. But this file is when once all the data was generated, they start to read it, okay. And this one they read the result back to the matrix A11, okay, for each column J, okay. J equal 1 to N1, okay, for okay, the default, okay, is that they're going to keep the data in the matrix column by column, okay. So once that's the default when you try to write everything back to the secondary storage, okay. And this one single is mean the single precision, okay. F read is a basic statement, okay. File ID, okay, refer to this one. We open the file called capital A11, okay, and we read the data N1 10 data at a time, okay. And the data was reading in the format that we call single precision. Single precision is mean that we're going to use around 4 bytes, okay, to keep one data, which is not very accurate and sometimes can lead you to some round off error. So maybe alternatively you might use double over here instead of single. Okay, f read, okay, it means that you read n1 data at a time, okay, and then put all the n1 data in the column J of A11 matrix. Okay, first A11 is the storage of the matrix, and then for n1 data at a time, put it in the column J, and then after that, okay, we get the square metric, okay, we'll repeat this loop n1 time 10 times, you get all the full data of A11. And so this one is F close. Okay, we close the file, and then we're going to measure how long does it take to install this. Okay, this is the way to read the data from the secondary storage. Okay, first of all, we have to construct the data first. Okay, and the file we call construct metric partitioning m by m over here. Okay, this one m is equal to 2 and n is equal to 100. Okay, m by m is mean that we can go back and try to explain that in the format that we studied before, like the classic 2 by 2 over here. Okay, this one is M1, 2 by 2, 2 by 2 submatrix. Okay, but this one N1 is 2, N2 is 3. Okay, so you have submatrix of A11, A12, A121, and A22. Okay, but this one is small illustration. Okay, but in terms of larger size, okay, in general over here you can have A1 size of N1 times N1, A12 size of N1 times N2, size N sub 2 times N1, and N sub 2 by N sub 2, with N1 plus N2 is equal to N. Okay, so this is the way we call the 2 by 2 system. In this case, M is equal to 2 and N can be any value. It depends on N1 and N2. So we go back to to the Matlab file again. Okay, so in this one, okay, we have N1 is equal to N2, which is 100. Okay, in this one N1 and N2 is 100. Okay, or we didn't distinguish the value of N1 and N2, but we want the submatrix of 2, size of 2. So you can see that there you start counting the time tick and top over here. Okay, so you start the loop for I equal 1 to m, for j equal 1 to m. Okay, first we call f, we start to set up the name. We call f name the file name. strcat is a kind of the augmenting the character altogether, string cat, string combine, something like that. We combine, we're gonna set up a string name or the file name called start with a, and then we would use the string I. String I is mean that they're going to convert the numerical value of I to the character. Okay, for example, if I equal to 1, string 1 is 1, but it's not the number, it's become the character, so that they can combine strcat that string I is mean that, and string j over here is mean that you're going to set the string character called a, and then the value of I and value of j. And when value of I and j is alternating from 1 to m together, so you can see that for every loop of ij, okay, they're going to set up a file name called a, and then ij. Okay, and then we're going to use this file name to open the file first. File this, open the file, and then the attribute of w is mean that you're going to write, because you're gonna write this file, okay, into your secondary storage. It's a different from the read file. Okay, you can see that if you open the file without any second attribute, okay, it automatically will be, you can see that you can read the file, f read. Okay, but if you want to write the file, okay, you want to put this one. Okay, this one is meant I open this file to write something, okay, to keep it into your secondary storage. Like in this one, okay, this is a file example we call A11, but this one is just for the file name A11. But if you go to this construct metric partitioning, is more generalized that, okay, because for the file will be open, this one N1 is equal to N2 is equal, it means that actually I have the metric of size 200 by 200. So I'm going to separate 100 by 100 of A11, A12, A21, and A22. Okay, and each of them store in the metric in the file name called A11, A12, A21, and A22. So for each, you can see that A is equal to 0 of NN, which is the size of 100 by 100. This is submatrix. And then this is the command that I generate the value. Actually, in the reality, this is not randomly generated. You might retrieve it from some actual source of data. Okay, to write the different program to retrieve all those of those real data. Okay, to store in AKL. AKL is mean that the element and row K and column L in matrix A, small a over here. You can see that this is a loop that generate all element of AKL and it become the non-zero value. Okay, and then the next step is that instead of using fread, I'm going to write this data, the data of A matrix over here, AN. I'm writing it into the file ID. File ID is over here. I open the file called AIJ. Okay, and then I put all the value of A here, the matrix A. Okay, and I keep it in the double. You can see there is the difference from the read file. The read file you say that single, but since the number over here is a rounding number, and you can see that we use a random number which is uniformly distributed from 0 to 1 times 10 plus 10 with the second two digit of accuracy. Okay, this one, so it become the value with two digit number. Okay, and we use this round. Okay, they're gonna round up or round down. It depends on the value of the two digit of the number after the integer number. Okay, so after we write all element of matrix A, okay, into the file ID, which is the name of AIJ, we close the file, and then we repeat the loop again. With the new loop, there going to be the new ij, so the name will be different because the name start with a and then I and j as a number, but converted to connected with the a character over here will become different. Okay, once the file name is different, every time the loop they repeat the loop. Okay, so in this case, okay, we mostly the default over here, you can see that this is the default drive. Okay, on drive C. Okay, my installed Matlab recognized that. So when I didn't open I didn't give the directory for this file name, they will automatically create a file name here in this default drive that you see up here. Okay, so I'm going to execute and try to run this program. Okay, first of all, okay, we go back into, let's check at the drive first. Okay, over here. Okay, we go to download. You can see that download over here. Okay, they still have B1 and B2. I'm gonna erase it. Okay, I'm gonna delete, and then B2 I'm gonna delete. So there's no existing data file over here. Okay, so let's keep it this way, and then we go back and try to execute this file. Okay, of clear. Okay, I'm gonna run it. Okay, so once you run the program over here, it's gonna show the execution in the command window. Normally with the platform of Matlab, there exists up to main window. The first window is we call the editor window, where you put the sequence of command, okay, or the code or program, whatever you call it. Okay, and then once you execute this editor sub command over here, you execute the run command over here, they will run the active the active page that show on the editor window. Actually, I already download a lot of program, okay, from that drive, okay, over here, okay, from this drive of Matlab, where okay, to the current directory, okay, the default directory of my installed Matlab. Okay, we start with this one first, the construct matrix partitioning m by m.m, which is one part over here. This is a program construct. You can see that there's a document file over here, the same file. Okay, okay, I actually the same data over here as you can see from here. Okay, Maybe you look in this is much better because I can control the size of the character so that you can see on screen clear. But actually, it's the same program. Okay, so many of these programs have been downloaded to utilizing this Matlab environment. Okay, so you can see that I already execute this file. So what was the result of executing this file? It take maybe less than 1 second, or maybe 15% of 1 second, very fast. But look at what they're doing. They construct a metric of size, uh, partition metric to size 200 by 200 to 4 submetric called A11, A12, A21, and A22 because M is equal to 2. Okay, for ij equal 1 to 2, j equal 1 to 2. So this file name can have A11, A12, A21, and A22. Each of them have the size. You can see that the size for k over here that generate this small metric A, and then I write all this data of metric A in the double precision accuracy. Okay, and then I close the file. So in the next round, the new ij, the different file. So let's go back to the default drive. Okay, you can see at the default drive of your PC. You can see. Okay, I download. You can see that the previous one we didn't have this. A11, A12, A21, and A22. This is a submatrix, okay, of size 100 by 100. Create occupy 79 kilobyte, okay, on your secondary storage, which is now is my drive, sub drive of this PC of the sub drive download, okay, that is a part of my hard disk, okay, and you can see that it takes very less time, so you can keep increasing the sizes. You remember that when we use the Excel, we run into the problem when the size become thousand by thousand. Some machine didn't respond very well. Okay, but I'll tell you, actually the computer that I try for you over here is size maybe it's only I core T3, core i3 or something, and it can run up to around 10,000, which is the comfort zone. The comfort zone is increasing a lot, 10 times as compared to the Excel. That's because this is a commercial software. It would be nice also if you might try to use generative AI and then convert this Matlab file to Python that you familiar before the midterm exam. Python is open source, okay. Maybe the comfort zone of the largest and can be smaller than Matlab. If it's better than Matlab company will be bankrupt. They're not going to be able to sell the software because so they have to perform more efficient and more effectively, okay, so that people can willing to pay and purchase the software, okay. But this one is just a tryout, okay, for you that and you can see that I can keep increasing this value m to 10, m to 20, whatever, as long as I have enough sufficient space of my hard disk, okay. Okay, and but this just to show you that I already construct this matrix for the A11, A12, A21, and A22. Okay, and then the next step that I would do is that I you can see that this is the way that I can read the data. Okay, this is just a sample file called A11. Okay, I read. Uh, how do I know that if I'm gonna read the data back and store in the metric? You can remember this one, I construct a metric and then I write it into a file, okay? And when I write into the file, okay, you can see that I have the whole matrix of A, small a here, and write simultaneously here. But when I read it, you can see that as a matrix, you might wonder that it's gonna go one row at a time. How do the data in the matrix store in your file? Because you can keep, okay, row by row, okay, or column by column. But in the command they didn't tell you. Oh, sorry. Oh, what did I done? A, small a, okay, and then up, up, okay, this one is a, I write the whole A matrix. I store each data on each row and column element as double precision. Double precision is mean that one number occupy 8 bytes. Okay, and I know that the original data only have a 2-digit rounding. Okay, because of the way that I generate the data over here. Okay, but how do I know that when I write the whole metric, are they gonna in, uh, store the data row by row or column by column? Okay, the default, okay, from the write statement is over here is explaining in the read statement over here. You can see that once I read it, I cannot read the whole matrix at the same time. When you write it down, okay, I think in the over here I write down, I write the whole matrix A, but I didn't tell them that okay to keep row first, to keep row by row or column by column. I didn't know that how they store it. But when you read it, okay, you read it. Yeah, I cannot read the whole matrix A11 over here. I can only read row by row or column by column. But how do I know that this N1, okay, this one, if you, I keep it this way, I keep the command this way, is mean that each the way they store the data sequentially is by column by column. Okay, that's the default. Okay, if you didn't tell them anything, that's why this is a clear statement over here that when I read it column by column, and then once the first column, okay, I put in a column J, the second column. So I cannot read it back the whole matrix at the same time. Okay, I was out of campus, so I need to using OpenVPN. Okay, so okay, I'm going to install back. As you know that since Matlab is university license, so you need to install, when you use it out off campus, you need the OpenVPN. Okay, so now all of this has been installed. Okay, so and you know that how do I read how I can write the whole metric by using uh, this statement or this set of sequence of the command, but when I read it I can only read it column by column. But there may be a way that you can read the whole metric at the same time. Okay, but this one is just the way that we didn't to tell you that by default, okay, when you read the data from a sequential file that you install the whole metric, when you take it back it's gonna read column by column, not row by row. Okay, you can see when you write, you can see that this is the same that for just single file of A11. I can write the whole A11 over here, you see. Okay, but when I read it, I have to read it column by column. Okay. Okay, so the next step, this is the first three program. Okay, read, write, and construct metric, and then you can find all of this file here. Okay, this one, the construct matrix, and you can have a file called read and write over here. This is a read file. Okay, in words. Okay, the same file, the same command. Okay, and this is a write file. Okay, how do you write the data on your secondary storage? Okay, okay, the same file over here. Okay, let's go to the next program. The next program we call metric partitioning 2x2 linear equation. Well, actually, what this program do, okay, is exactly the same as what you did in this file of your Excel file. You go back to the Excel file. You might remember this file, this one, copy of P, this file. Okay, maybe I instead the detail file. take some time to read because it's a large file, you might recall. Yeah, it's 113 megabyte. Okay, this is the file that metric partitioning for 2 by 2 linear equation. Okay, it's one of the assignment that I want you to expand for 3 by 3 case. Okay, so this one is actually in the Excel format. Okay, but in the Matlab format, okay, it's actually in here. Okay, we call this one, this inverse. No, not inverse. Where's the file? Huh? Where's the file? It should be this one. No, this EB11 should be this. Yeah, this is the one. Metric partitioning 2 by 2 linear equation. This is the same as program that I put it in here. But this one, you can see that in this file, I use the n sub 1 is 10,000. This is a very large scale problem. Okay, actually it was 20,000 by 20,000. But it took some time to execute it on my, so I reduced the size to only 100. Okay, n1 is 100. Okay, actually this one you can have different n1 and n2. And n2 is over here. Once you identify n1 here, okay, n2 is here. Okay, and then okay, let's see how the metric partitioning work. Okay, I generate b1 as a right hand side vector. Okay, you can if you go back to the lecture part, you can always refer to this part. Okay, this program just executing this one, just executing this one, which means that when you have a partitioning of a11, a12, a21, a22, and you have a partitioning of the right hand side vector of b1 and b2, so in the Matlab program you have b1 or partitioning 1 to n1, and then you have b2 later. Okay, this one b1. Okay, and then I just write b1, okay, into a file called b1, keep it in a double precision, and then I close the file, and then I start to do a stopwatch tick tock, okay, to execute over here. This one start from that. Okay, I need to open the a11 first, and then I get the value of a11. This one is coming from the read file. If you remember that, this read file, this read routine, okay, is borrowing those commands to read the a11 from the file called a11. Why? Because you go back and here you need a11 inverse, okay, time a12. Maybe it's easier for you to look at here. Okay, it's a step by step. Okay, you need to find a11 inverse. Okay, and then you can see that over here. Okay, once first I generate b1, okay, as a round random time 50 with the two precision, digit precision of 2, uh, and then I generate b1, and then I open and write b1 into this file, and then I start. You remember that the first program over here, we construct submetric a11, a12, a21, a22, and it's already here. You can see that already here, a11, a12, a21, a22. Okay, and then with this program, okay, you can say that, okay, I have a11. Okay, this is a read file of a11. Okay, and then after I execute, I get all the a11 value. I find, instead of in term of memory saving, I can use this statement. I get the new a11. Okay, I count another time, tick tock over here, executing. I find the inverse. This is the inverse command. Actually, it's very convenient. I just put this command and then I put the metric, just like you use M inverse in Excel. This one in Matlab, you use inverse and then you put the metrics in of A11. A11, you already read it, okay? You already read the file here, and then you have inverse of A11, okay? And then you get the new value, put it in not utilizing the new metric. That's gonna cost you some additional memory, okay? Twice, okay? Instead, put the new value into the original A11 here, and then I count the time tick tock over here. And then the next step, I go to N2, okay? And now I generate B2, okay? B1 and B2, okay? You go back over here, you can see that you need B2, okay? You need B2, okay? You need the original B2, and then again, after I generate the B2 value, and then I just save the B2, write the B2 into your secondary storage. And then I retrieve the new A12. Remember that A11, you already have the inverse of A11, not the original A11 anymore. The original A11 is still in the second storage. It's not been, even though in the main memory it was replaced by inverse of A11, okay, but the original A11 is in the secondary storage of the file called capital A11 over here. Okay, I can retrieve it back when I want to. Okay, for this one, okay, I want A12. This one, the file ID become A12, and then I retrieve column by column of A12. There I get the value. And then you can see that this is a key activity. The new A12 is A11. You remember this A11 is the inverse of A11 up there. You can see A11 is now it's inverse. So I'm using inverse of A11 times A12. Why do I do that? Because of this. Inverse of A11 times A12 is become the new A12. And then I'm using B1N. B1N is mean new. The new B1N. I'm using the A11, which is now is the inverse of A11 times B1, which is actually this one, the third activity here. A11 inverse times B1, this one. And then I compute A11. So now, when reaching this point of program at the line 39, we already accomplished these three activities, the first three activities. Okay. And you have to know that A12 is a new one. It becomes the inverse of A11 times A12. Okay. And the new B1, okay, is actually I can just put it in the original B1 because I don't need B1 because the B1 I already saved a file for the original B1 in this one, but that's okay. B1 is as comparing to the whole metric is require much less memory. This is the B new one. After this, okay, to save the memory, you can go back and look at here. After this activity 4, 5, 6, 7, 8 over here, I don't need the inverse of A11 anymore. The inverse of A11 is finished after this third activity. So to save the memory, I put this one clear A. This is not clear all. Actually clear the matrix of A11. Okay, okay, the pronunciation is clear all, not clear. Just clear this value, clear A11. The A11 has been clear, the value here. Okay, you remember that if you just use clear and then semicolon, just like the first statement of the most, if you use it, that's clear all. Everything was clear. Okay, you don't need all. Okay, so don't mistake this with the meaning of clear. Actually, we clear the whole metric of A11. It's going to save you the memory of size N1 times N1, and then you start. Okay, retrieve A22 from B22. Okay, this one is from copy from the read file of this one. I'm using this of A22. Okay, and then I count. I get why I need the A22 because look at the activity here. After this, okay, after the third activity, I will need to find A12, the new A12. Actually, the A12 now currently have the inverse of A11 times A12, and this one is for A12 B1 here. For the third, fourth activity, okay, I can use A21 times A12, and then I just find the new A22, but I need the A22 first, okay? So go back to this program again, okay? This one, I retrieve the A22, okay? And now I retrieve the A21, okay? This one, I retrieve the A21, read the A21, okay? Why I need A21 and A22? Because of this one. I need A21 to multiply to A12 part. And then to get A12, the new A12, and the new A12 is subtract from A22, you get the new A22. Okay, so this is what we want. You can see that once I get the A21 over here, I have A22 before. Okay, you can see that the new A22 is that you get A22 minus A21, okay, times A12. And A12 previously, what's the value of A12? The value of A12 is a inverse of A11 times A12. Why A11 is inverse? Because previously, this one, you get the inverse of A11, keep it A11, and when you execute this, you get inverse of A11 times A12, become new A12, and then you get A12 over here, which times A21, which is according to this formula. Okay, you get A21 times A12, which is A12 inverse of A11 times A12. Once you get A12 over here, you subtract it from A22. But I just combine these two, 4 and 6, to only after I know A21 and A22. Okay, to get the new A22 is a previous A22 minus A21 times A12. And then B2 over here, I can doing execute activity 5. The new B2 is a B2 is the original B2 minus A21. We already retrieve A21 times B1, the current B1 value, and which is this one. B1, the current B1 we call B1 in. Remember that? The new B1 times A21, okay, which is this one. The new B1, B1 new times A21, and then subtract from the original B2. B2 here. It become the new B2. And then in this program, in over here, but this one you should use B2N. Okay, but that's okay. Okay, I just replace this to the original B2. I don't need to worry about the B2 vector. Okay, because what? Because I already write the B2 over here. Put it in the file already. Okay, so once you get this B2, okay, the new B2, so now the remaining part is according to this. You finish the 6th activity, you can find x2. X2 is that A22 pi inverse times B2, the current B2 value. Okay, and in Matlab it's very easy. I just use this statement. The x2, the vector x2 sub vector is A22, and then this one, the reverse slash, okay, okay, and B2. This one is like it's the same. It's a command that it will execute A22 inverse times B2, which is what we want over here. Okay, this is the mathematic notation, but in MATLAB we use this statement. X2 is A22 here. It means that you find A22 inverse times B2. The current B2 is this value is B2. This one is B2 prime. Okay, A22. The current A22 is over here. You can see that. So you get X2, and once you get X2, you can find X1 according to these activities. You can see X1 is the current B1 and minus A12 times X2. So current B1, actually I should use B1. I should not use B1N. Okay, but since I already call this B1N, I have to refill that this B1N minus A12 times X2, and you can see that this is according to this one. Okay, you can see B1, the current B1 minus A12 times X2. Okay, and so this is, so I get the value of x1 and x2. Okay, and then after I get the x1 and x2, I just keep it in the secondary storage of your hard disk. The current drive is the default drive is a download, the name C, and user and download over here. So I'm going to execute this program. So I'm run it. So you can see that every TikTok they show the elapsed time, much less than 1 second, very fast. You remember that this is the size of 200 by 200. Okay, and then after this, okay, we go back and look at what's going on with this one. You can see that B1, B2, X1, and X2 is constructed because of the code over here. That once I generate B1, I put it in the hard disk as a file called B1, and then I put this in the file of B2 corresponding, and then I'm using, after I solve for X1 and X2, I get this X1 and X2. So this is all the results have been solved according. You can see that I have with given B1, B2, I can find X1, X2, and all solved. The problem of 200 by 100 solved. But the next step is that how do I know that the solution is correct? How can I make sure that do I get the solution right? Okay, I have another program we call check 2 by 2 case. Okay, actually you can download it in here also. It's in the Matlab file. You see the check 2 by 2 case over here. Okay, the same file here. Okay, but this one I do experiment of size 10,000 by 10,000. Okay, but in this case I have a check file over here, but then I check only case of 100 by 100 over here. How do I check the results? Okay, it's very easy, and then directly can be execute, okay, by using this properties. Okay, you can see that with this partitioning, you can see that A11 times X1 plus A12 times X2 have to be equal to B1. And A21, the partition times X1 plus A22 times X2 must be equal to B2. Okay, so I have this, okay, this check file to check. I just put the N1 and N2, and then I open the file of the results of X1 to get X1, and then I get X2, and then I start opening A11. Okay, and then I check the left hand side starting with A11, start left hand side one, A11 times X1, which is follow this A11 times X1, and then okay, I clear A11. Why clear A11? Because I don't need A11 anymore. So I can save the memory. So I use A12, okay, which is size of N1 times N2. Okay, and then I open A12, and then I read the, oh Jesus. I should not, what's wrong? Oh man. A12. Okay, okay, this one A12. Okay, if read, after I read the A12, you can see that left hand side, the first left hand side is the previous one A11 times X1, and then A12 times X2. But remember that after this A11 not utilizing anymore, so I can save the memory too for evaluation. So left hand side 1 become, okay, A11 times X1 plus A12 times X2. Okay, and then I clear A12. Okay, and then I start doing something again with A21 and A22. Actually, just repeat each the first left hand side one is A11 times X1 plus A12 times X2, and then I clear both A11 and A12, and then I retrieve A21 times X1, and then I clear A21. Okay, and then I retrieve A22. Okay, and then I use A22 times X2, and then put all the two value together to get the left hand side too. So this is what I've been doing for this check program. That okay, I get A21, and then you can start with A21 times X1, and then I create A21, and then I occupy define the new space of A22, and then I open A22. So I read A22 again, and then you get left hand side 2 of A22X2. Okay. To check it, that's the left hand side. The right hand side is file B1 and B2. You remember that B1 and B2 automatically install here. You have B1, B2 over here. Okay, so in this case of this file, okay, I get right hand side 1. Okay, this is B1. Okay, to read from the file B1, and right hand side 2 you get from B2. And then after I retrieve all necessary data, I get the maximum one is the maximum, the absolute difference between left hand side and the right hand side, which means that row by row, the same location of two vectors of left hand side and right hand side, the first left hand side and right hand side. Okay, I find the maximum absolute, the difference. Okay, and max2 is also the maximum absolute, the difference. And then my check max is that I find the maximum value of the maximum 1 and maximum 2. So after finishing this, okay, if I execute this, okay, so take less than a minute of 2 by 2. If I print the value, you can see that I haven't used the clear statement at the end of the program. So I check the value, I pick this check max over here. Okay. It showed that 8.4825 e exponential times 10 to the minus 11. So it's very close, very small value, close to 0. This one check the maximum error between the left hand side and the right hand side, row by row. Okay, so they check this one, check this one, the difference between this and this, the left hand side and the right hand side, row element by element, and pick the maximum one. The check max is the maximum value. Okay, in the Matlab here, which is very close to 0, which means that the left hand side and right hand side almost equal to each other. This one is 10 to the minus 11. It means that the difference started the 11 digit. Okay, the first 10 digit, okay, with the integer value in front, left hand side and right hand side have no significant difference, have no difference, let's just say, absolutely accurate. But the difference start at the digit number 11, okay, and this is the maximum error here. Okay, it would be fun to see that this check mark, if you keep increasing the size, okay, this check mark having some effect if you really trying to check it out. Why? Because as the size getting larger, okay, the cumulative round of error of the left hand side require more computation of the larger size. Okay, so the cumulative error keep pounding up. Okay, and there might be some case, okay, which but actually rarely, unless you have a decided case that you some mathematicians have developed that we call the yield condition, right, of some system. But most likely at this moment, if the problem is not have a very special structure, okay, this direct approach can don't have to worry about that situation. Okay, so I see. Now we move to we have given you 5 program, okay, for solving this equation. Okay, and you all know that this is and I would like to show you a little bit about the circumstance when we solve a very large scale problem. Maybe we go to the Matlab file. I show you that. Okay, this is the case where I didn't run it for you, but I take a picture after I finishing it up. Okay, we construct the matrix. This is a case of 2 by 2, and n is equal to 10,000. Okay, if you recall this, actually start with this program. If we change n this to 10,000 and m is equal to 2, and then the same as over here, the programmatic solving. I change N1 to 10,000, N2 to 10,000, and then the same as we check N1 and N2 is 10,000. This is the results that I kept the picture for the final results for you. For it took this one on my machine. It took maybe almost 5 minutes to create the file. Okay, 287 87 287 287 second. Okay, almost 5 minutes. Okay, to construct A11, A12, A21, and A22 of the size 10,000 by 10,000, and it's capable of store in your hard disk. And then when I solve this, oh, this one is for inverse. Sorry, I didn't. I should have checked. I didn't make this. Sorry. This is one for the inverse file, but I think that okay. 2 by 2 case. Okay, this one also for the inverse file didn't take that long. Okay. Oh, okay. So this one I just check you with the check mark of the 2 by 2. This one is for inverse. We'll talk about it later. But this one is directly the same file as we are doing here. To check 2 by 2 case over here. Okay, this is one I want to show you. With the size of 20,000, which means that 20,000 check over here is mean that now we have N1 and N2 is 10,000. The construction file is over here. 10,000, 10,000. 2 by 10,000 by 10,000. Okay. You can see that once the problem been solved, the check max is something like this. 3.3 times 10 to minus 7. You remember the size of the 100 that we just tried over here? The check max is 10 to minus 11. You can see that the accuracy start to reduce. Instead of the digit number 10 or 11 in this case, once I increase the size to this one, okay, 20,000, it becomes this. And then if you go to this one 30,000. 30,000 by 2 by 2 cases mean that this is become 15,000. M equal to 2, N is equal to 15,000. But in this case, I just, you can see that it take longer time to execute from previous one around. But actually, this is not the machine that I show you here, because I tried this case when I was in my office, which the machine is much more efficient, so it take less time. Okay, but I want you to see that the check mark, you can see the effect. You can see that from here, it's a 10 to minus 11, the 11 digit, okay, with the size of 100. But when you come here, the size become 2 by 2, okay, for each one is 10,000 by 10,000. The sub matrices become 3, the 7 digit. And then as we move to 2 by 2, each with 30,000, it means that 15,000, the check mark. You can see that the larger size of the problem, okay, computer cannot work in the direct rational number. They 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 have a round off cutoff digit because of the finite number of byte to store a data, as I show you, the single precision or double precision, whatever. So the more computation, okay, required, the round off error keep accumulate. Okay, but this one, when you traverse 30,000, the accuracy become to the 5th digit. So when you work on a very large number, large size problem, okay, sorry, and you have to make sure that to check this, and sometimes you might to add some additional required special precision for mathematical operation to control, not just using the default set by the program. Okay. This is just an illustration for you to show you that for the check program. Okay, so there you have it. Okay, I have this the first 5 program for you. Okay, we're not talking about the find the inverse yet, but we talking about this in your next clip. But from now, certainly the homework for today is the same as what you find in the Excel format. Okay, but you can see that with the Matlab platform, the sub-matrices are allowed to, in this case I try 10,000 by 10,000, which is 10 times larger than 1,000 by 1,000 of the size of 1,000 by 1,000 when we try on Excel. So certainly the comfortable zone of execution of Matlab keep expanding, leading to a more efficient response, okay, of the program. And we might, okay, go with this results, okay, we can go to the case of, you can see that, you can see, as I show you here, I solved the 30,000 case over here, 2,000 by trying to change this one experimentally, and then with this construction matrix, and then this one is solving a 2 by 2, and then I'll check the results here. I can, with this tree program, I can keep increasing the size of the problem, checking the accuracy of the left hand side, the rightness of the results. Okay, and you can try on your machine that you own. Okay? And to find the appropriate, maybe like size of 30,000, 40,000, 50,000, because each of you own different computer with different efficiency. So the homework for today is that now the program was directly with 2 by 2 system, but you all know that the 3 by 3, because I already give you the lectures of when you're trying to solve the 3 by 3 case of this one. It's in page 6 over here. We already talked about this, but we implement on this one is 3 by 3, right? A 3 by 3, and we even have this work breakdown structure that we, okay, and this one is the inverse, but for this one, solving this. Okay, so the homework for today is that you can adapt this, okay, code of the construction. You don't need this, you need this to construct. You might change m to 3, and n you can increase as large as your machine can handle, and then you adapt this metric partitioning to the new program we call 3 by 3 by expanding the idea from 2 by 2 case, okay, using this work breakdown structure, the same as when we do with 2 by 2. The 2 by 2 code, okay, of Matlab was developed by this work breakdown structure, but for 3 by 3 you have this work breakdown structure. Okay, rewrite and modify the code over here, and the same time you can expand it, the check of 2 by 2 case to check of 3 by 2 case. Okay, so that in order to check 3 by 2 case, very easy. This one, you get a11x1 plus a12x2 a13x3. This can be like left hand side 1 and check with b1, and a21 times x1 plus a22 times x2 plus a12 times x3. That's left hand side 2 times check with b2, the maximum absolute error. Okay, and check maximum absolute error for the third, add another one left hand side 3, a31 times x1 plus the a32 times x2 plus a33 times x3, checking the maximum difference with the b3 absolute difference, and then now you have a maximum difference of 1 2 3, and your check max become the maximum of these 3. Okay, something similar to what you do with 2 by 2. So the homework today is that so you can expand the idea of uh, what I'm doing with this two program of metric partitioning 2 by 2 linear set and the checking of 2 by 2 case by utilizing this two lecture note, okay, of this one. Okay, this one is to check the left hand side, right hand side, and this one is for uh, work breakdown structure to adapt the program. Actually, some of them is already there in the 2 by 2 case. You just need to write additional file, additional program. Okay, and you make sure that you have to be able to find x1, x2, and x3. Okay, and then you check it just like me, check the maximum value of the different. And you might show you me just like what I did with my uh, results over here, that I check the maximum difference, that as the size of problem keep increasing, the maximum difference keep reducing. Okay, which make you to aware that when you're facing a very large size, the cumulative error can have an effect, and you need to check it. Okay, so that's about it for the starting point of the Matlab platform over here. Thirdly, in the next script, we talk about the remaining code of Matlab code, okay, that I show you here, the remaining part up here. Okay, we're certainly gonna deal with finding the inverse matrix, okay, in a partitional large scale dense matrix form. Okay, so see you down there. Okay, but from now, okay, I hope you understand, and you don't understand, you repeat watching it, and then make sure that you understand the homework assigned according to the lecture of this clip. Okay, see you in the next clip.